Hey everyone, in this video I'm going to be talking about my competitive programming setup. In particular, I'll be covering three main topics. The first is the terminal I use, the second is my editor and how I write code, and the third is my shell scripts and how I stress test. I should note that this isn't intended to be a comprehensive installation guide, and I probably won't be able to answer most questions if anyone does try to replicate the setup, largely because it's very difficult to diagnose these sort of configuration issues as an outside observer, but I've included links to relevant tutorials in the description in case anyone's interested in installing any of the tools that I use. So let me start by talking about my terminal. So as my terminal, I use the Windows Subsystem for Linux, or WSL, which is probably best described as a Linux command line for Windows. And I use it largely because it's necessary for my stress testing scripts. There are also a few Linux-related utilities that I use for non-competitive programming reasons that are pretty useful. It's technically possible to write a stress testing script for the Windows command line, but it ends up being a lot slower. The Windows stress testing script that I use processes around 10 tests a second, and the one I have on WSL processes roughly in the range of 100 tests a second, and so there's a pretty significant speed difference. So I've included a link to the official WSL setup tutorial in the description. You'll probably need to do the manual installation rather than the simplified one, just because, or unless you're a member of the Windows Insiders program. But yeah, so that's how you can set up WSL. I use the exact distro you use probably doesn't matter that much. I use Ubuntu just because it's pretty well documented, and so that made it easier when I was looking up configuration issues I was having. But obviously, if you're more comfortable with something else, you can use whatever you want. I should also note that the rest of the tutorial will be equally applicable to Linux, or to if you're running native Linux rather than WSL, or even if you're using a Unix-style command line on a Mac, as long as you have G++ installed. Alright, and so as far as the specific terminal emulator I use, so Windows provides one with WSL, but I choose to use WSL TTY, which is a version of the PuTTY terminal designed for WSL. And a setup link for WSL TTY and for its solarized light color scheme, which is my theme of choice, are in the description. And let's see, I've included this link, and it includes both a tutorial on downloading the terminal itself and getting the color scheme that I use. As I recall, I haven't done the rest of the setup. I just so you can just focus on the color scheme and then the base installation. Okay. So after installing WSL, you'll need to make sure to install G++ if it isn't already set up. If I recall correctly, G++ was pre-installed on my distribution, but if it's not there, then you'll need to install it. The other thing you're going to need to do is you're going to need to place a command in your .bashrc file to remove the stack size limit, because the default stack size limit that comes with G++ is fairly small, whereas on Codeforces, your programs are compiled with a 256 megabyte stack size limit. And so programs that declare really large arrays on the stack may end up crashing on your computer when they run fine on an online judge. And so to prevent that sort of bit of inconsistent behavior, you'll need to add a line to your bashrc that I will show you real quick. So that this is ulimit-s unlimited. I pasted this into the description, and that basically removes the stack size limit entirely. The reason I removed the stack size limit rather than just setting it to 256 megabytes like Codeforces is because some other platforms have other stack size limits, and there's some contests like Facebook Hacker Cup where you may need to run a program on large inputs on your own end, and you may want to have a larger stack size limit for that purpose. So I just set my stack size limit to unlimited, and then I just have to be careful myself to make sure that I don't end up writing a program that uses too much stack space. So the command is in the description. Now, as far as my folder setup, it's fairly simple. In fact, there are only two main folders I'm going to need to tell you about now. So the first is my main competitive programming folder, and within this folder I have a separate subfolder for every contest that I do. And so, for example, if I go to the Div2 round that was 2 days ago now, that had a contest ID 1526, and so back when I was competing, I made a folder CF1526 for it, and I'll show you what all is in here. As you can see, I have my solutions to the 6 problems. I also have a few additional files that I wrote. As you can see, I have a generator and a slow solution for C, and then I wrote an interactor for F, and that happened when I was stress testing those problems. And so I'll be getting to how I stress test in a moment. Okay, and then the other folder that is relevant is I have a scripts folder, and this is basically where I store all of my shell scripts that I use for stress testing. Again, more on that in a bit. Okay, so let's go over my editor. My editor of choice is Vim. Obviously, you can use whatever you want, but I like to have the nice shortcuts. I should note that you can only run Linux command line editors within WSL. I've heard that there's a workaround to get Linux can't remember what the word is, but Linux graphical applications to work, but I haven't explored it yet, and I've heard it's kind of a pain to set up. But that said, you can also just access files through Explorer and run your preferred editor from Windows, so you're also welcome to use a Windows application or a different Linux command line editor. And let me show you how to access your Linux files through the Windows Explorer. So if you're using Ubuntu, then what you're going to do is you're going to go up to the path editor here, and you're going to type in //WSL$Ubuntu. And you go here, and it will take you to your base directory, and you're going to go to home, and then you're going to click your username, and then that'll get you into your main folder. And if you're set up like me, you'll go into your competitive programming folder, and then let's say I want to go edit a file here, and then if I want to say like write some code or edit this file using Genie, then I could just I could just open it with Genie. Alternatively, you can just so if you want, you can just create a new file from the Explorer and then edit it in your IDE of choice. But anyway, I choose to use Vim. Okay, so as far as my vimrc, let me open it up and I'll walk you all through it. So these first 17 lines or so just include some general editor settings just to make life a little easier. I'm not going to go over all of these in detail since they're well documented online. The main one that maybe is a matter of personal preference is I use relative numbering rather than just numbering itself, and this means that the number next to my current line displays, but then all of the other numbers represent the distance between my current line and the line they refer to. And this is helpful because for when I'm using Vim hotkeys to jump around. Like for example, if I know I want to go to this line about my other key bindings, I can just press 12 and then go down. Okay. So these next lines are these next lines define my theme. You're going to need to get the solarized Vim theme, and I'll put a link to that in the description. You're also going, and keep in mind that this theme is going to require you to also have a solarized light terminal theme in order for the colors to look right. And so again, if you're using WSL TTY or if you're using PuTTY on Linux, the links for that are in the description. Otherwise, you're going to need to find a solarized terminal theme for whichever terminal emulator that you're using in order for this to work properly. Okay, so here there's a few more key bindings. The first one is just bracket auto-completion. This one maps JK to escape because I find that hitting the escape key is kind of a pain. This one allows me to use Control-A to copy all of my code. Okay, so this next line basically whenever I create a new C++ file, it types in my template for me. And so if you use my vimrc, you are going to need to replace this with a line to with the path to your template. Now these next two lines are pretty important. They're how I compile and run. So this line makes it so that whenever I press the F9 key, my code is compiled. Now you could just put a G++ command in here, but instead I use build.sh, which is a shell script that I wrote that builds my files for me, and I will show you what that looks like in a moment, and I'll put a link in the description. This does mean that if you want to use this command exactly, you're going to need to use the build.sh script. Otherwise, you can replace this with the G++ command to compile it directly, and then F10 just runs the compiled program. Okay, these next few lines are some latex settings, so they're not going to be important for competitive programming. Then I have some plugins set up here. As you can see, I don't exactly have a large array of plugins I use. I like to go with a base setup, especially because it makes it easier to adjust to on-site contests because I'm not missing any tools that I'm used to. And so all I have is Vim text, which again is for LaTeX, and then a highlighting plugin, just because I think it looks better. And then these are a few more latex settings. And then finally down here, this is a block of code that basically makes it so that I can copy code from Vim into the Windows clipboard. Yeah, so you'll need to put this in here in order for the Windows clipboard to be compatible with Vim. All right, awesome. So that's my vimrc, and then the other thing I should go over is how I use my library. So if we go into vimcp, what I do is I store my library in this library folder. And so you can see I have quite a bit of code in here. I'm not going to be releasing my library just because, or first of all, because most of it is copied from other sources, and so I can't really claim credit for the majority of this code. And secondly, because a lot of it is not like particularly well tested or maintained, and so it may be a little bit confusing or difficult to use. But yeah, and so when I want to use this library, let me cd into this demo folder I've created. So we go into this test file. So as you can see, first of all, when I created this file, it was filled in with my template. And then what I do to add a file for my library is I do :r /library/ let's say I want to add the modular int template, then I would do mi.cpp. And then the mod int template will appear in here. So yeah, basically :/library/mi.cpp is the relative path to my mi folder, and so in order for this to work, you're going to need your library folder is going to need to be a sibling of the folder that you're currently working in. Okay, great. So I think that's all I have on my editor. So now I'm going to talk about my stress testing scripts. So for anyone who isn't familiar with what stress testing is, the basic idea is if you have a program that is that's wrong, but you don't know what test case it would fail, and you also potentially have and you also know how to write a solution that is correct, but it probably is too slow to get a C. Stress testing is a way to use those two solutions to give you to generate a test case on which your wrong solution gives an incorrect answer, which then makes it much easier to debug. So let me show you my script folder again. The one that I'm going to talk about real quick separately is my build.sh script. And this is just a way for me to compile my code. And so the idea is, so $1 is filled in with the argument. And so the idea is if I run build.sh A, then it's going to compile a.cpp into an output file named A. And this is useful because typically on Linux, the output file is the output file for any C++ compilation is just labeled a.out unless you change it. And so, and that can be bad because it means that if you compile multiple files, then the last one you compile will replace all the others. And so by compiling every a.cpp to a file named A, b.cpp to a file named B, I can have multiple compiled files in my folder at once. Okay. Now in order to use these scripts, I've included links to all of my scripts in the description, and I'll be talking more about these other three: interact, stress, and validate in a moment. But in order to use any of them, you're going to need to go into .bashrc, and you're going to need to add this line export path equals $path : ~/script/. And that basically adds scripts to your path, or which ensures that you'll be able to run all of them from anywhere on your computer. And that way you don't need to copy the script into every single folder in which you want to use them, because they'll be accessible anywhere. All right, so now let me go over some examples. And so I prepared some demos for all of these, just with a few very simple tasks. So let's say that as our first task, we're just given two integers a and b, and we have to print their sum. And let's say for some reason we wrote this wrong solution that it reads in a and b, and then it outputs a plus b plus 1 for some reason. And let's just say for the sake of argument that we have no idea why this is incorrect. But we also have this slow solution that computes A plus B by using loops, by going up to A and adding 1 each time, and then going up to B and adding 1 each time and printing the answer. Yeah, and so this is the general setup we have for stress testing. We have a problem where there's only one correct answer, and we have a program that's wrong, and we have a program that's right, but it's too slow. So what we can do here to stress test it is we're going to need to write a generator, and that's in agen.cpp. And so what this generator does is it lets A be a random integer from 0 to 10, and B be a random integer from 0 to 10, and it prints them. This UID macro is defined in my template, and it basically UID of A comma B prints a random integer uniformly distributed from A to B inclusive. Okay, so I generate so I have this generator, and then this is where we get into the stress.sh script. So basically, the general format of stress.sh is you run stress.sh wrong solution, slow solution, generator, and then a number of tests, and then it'll print out a test on which wrong solution and slow solution give different outputs. And so if I want to use it here, I would do stress.sh a wrong, a slow, a gen, and let's say we want to run it on 100 tests. And it'll tell me, okay, there's an error. The input is 9.7, and then a wrong gives me a 17, while a slow gives me a 16. And so now I know I can go in and I can figure out in a wrong why it isn't outputting 17. And so just to show you what happens if your solution doesn't, or if you have a correct solution. So here's the correct solution I wrote, just adds A and B, as you might expect. Then I can do stress.sh a slow, a gen 100, and it passes 100 tests pretty quickly, actually. All right, so yeah, so that's how stress testing works. Now, one issue you might run into occasionally is that in certain problems there can be multiple correct outputs. And this is particularly prominent in constructives. It might be you might have 2 correct solutions that give different responses, and so this stress testing system won't work because your solution might be correct, but it might still give different output from your solution. And that's where validate.sh comes in. So let me first show you the second sample task. So here I've given just a simple trivial constructive task. We're given an integer a, and we have to print 2 integers b and c such that a plus b is equal to c. And let's say you have a wrong solution where you just let b be a random integer from 0 to 1, and then you print b, and then you just print a again. Now, whenever b is equal to 1, this is going to be wrong because a plus 1 is not equal to a. So this solution is wrong. And so the way you can stress test if you have what you need in order to stress test when you have a constructive problem or a problem where there might be multiple correct answers is you're going to need a generator again. So let me show you the one I wrote. This just lets a be a random integer from 0 to 10 and then outputs it. And then what you're going to need is a validator. So how a validator works in my system is it's going to be passed first the input to the original program, so this value a, and then it's going to be passed whatever your program outputs, and so here that's b and c, and then after it receives the original program's input and your program's output, what it has to do is if the output is correct, it has to print out OK, all caps, and otherwise it has to just print out anything else. And so here I just check if a plus b is equal to c, and if it is, I just output OK, and otherwise I say, no, this is bad, and I explain why it's wrong. And so now I can use my validate.sh script, and the general format is you have your solution, a validator, a generator, and the number of tests. And so here, I would use b wrong, b val, b gen 100, and yeah, here you can see that I put that my input was 6, and then I output 1 6, but that's bad because 6 plus 1 is equal to 7, not 6. Okay, and again I wrote a correct solution here, I just let b equal 1, and then I output b and a plus b. And when I don't have an error, it just passes 100 tests. Nice and easy. Okay, so that basically lets you deal with constructive problems. And between those two scripts, those will let you stress test the vast majority of problems. But there's one category left that these don't deal with nicely, and that's interactive problems. And interactive problems are particularly annoying to stress test, and the script that I have is pretty janky. But I do have a stress tester script to use, and so I will go ahead and go over that now. I should note that there's an additional file that's necessary for the interactive script to work in addition to the interact.sh script that I've linked in the comments. And so let me show you that right now. So what you're going to need to do is you're going to need to go into your library, and you're going to need to to add a file runner.py that I've linked in the description. I did not write this file. I actually don't remember where I got it. It was a while back. But yeah, this is not mine. And so this program essentially lets you put in two programs and run them against each other. And so you're going to need to to put this somewhere on your computer, and then in the interact.sh script, you're going to need to include a link to the path to runner.py in this script. So if you decide to try and use this script, you're going to need to replace this with a path to your runner.py. Okay. Now let's go back to the demonstration. The third sample task is just to process a number of queries interactively, where for each query you just have to add two numbers. Okay, so let's say we have this wrong solution here. And again, we're going to read in A and B, and we're going to output A plus B plus 1 and flush the output. Okay, so this is wrong, but then the way we can stress test it is we're going to need to write an interactor, and the interactor is going to need to generate a test and then essentially play the role of the judge and interact with the participant's program, or I guess your incorrect solution. So here what I do is I generate and output a number of tests, and for each test I output the test case, and I then read in the program's output. And if the output is wrong, then I say, okay, no, this is wrong, and then I immediately close the interactor. And otherwise, I output okay. And the key property that the interactor needs to have is it needs to print okay at the end if and only if the contestant's output is correct. Okay. So now I can use interact.sh pretty similarly to the other programs. I use my wrong solution, my interactor, and then the number of tests. And yeah, so this is going to be pretty janky, especially because a lot of time the way you'll write your interactor is a little precise. So like, for example, is a little imprecise. So here we end up getting like a few just error outputs, and this is because even after my interactor terminates, my wrong solution keeps trying to read input, but it'll still give us the test or the interaction that generates the wrong output. And so here, like, the interactor says there are going to be 3 tests, and then it says the first test is 1, 6, and my program outputs 8 instead of 7. But then if we have a correct solution, like so, just pretty simple code, I can then interact.sh C interactor 100, and as you can see, it's going to take quite a bit longer than for the other scripts, and this is just because piping the two programs to each other is not a particularly efficient operation. But a couple of seconds later, we do end up seeing that it passes all 100 tests. So yeah, that is the script. So I think that is about all that I have to go over today. So yeah, if anyone has any questions, feel free to post them in the comments. Again, I may not be able to answer most or all of them, just because, especially if they have to do with configuring WSL or Linux or anything like that, just because I'm not an expert and diagnosing those issues can be really difficult. But yeah, I'm certainly happy to answer questions about my setup or how I use it. I do think stress testing, like, in general, I don't believe that the specific editor that you use or your general setup matters that much for competitive programming, but I do think having these stress test scripts has helped me quite a bit in some tricky situations, just because a lot of time in an actual contest, it can be a real pain to figure out what the error is in your code, but it can be really easy to write a quick slow solution and a generator, and at that point you can get a test to debug with, and that can make your life a lot easier. So yeah, thanks for watching.